I'm Bill McNeese, a physician anesthesiologist, member of the American Society of Anesthesiologists, and a board member of the Wood Library Museum of Anesthesiology. Anesthetic vaporizers are devices that are used to convert a quantity of liquid anesthetic into anesthetic vapor, and this vapor is then blended with some combination of oxygen and/or nitrous oxide and air to be delivered to the patient where it's inhaled and then becomes part of that anesthetic for that patient. Control of the concentration of the inhaled anesthetic agent then is an important factor in administering a safe and effective inhaled anesthetic. The importance of the control of the concentration of inhaled anesthetic agent increased as halothane was introduced into anesthetic practice in the 1950s. I have 3 anesthetic vaporizers from the collections of the Wood Library Museum of Anesthesiology with me today. Each of these would have been available for clinical use in the 1950s. Each of the 3 is a variable bypass device that uses a flow-over method of vaporization and wicking to facilitate that vaporization. They differ in other ways. The Ohio No. 8 vaporizer was available from the 1930s into the 1960s. It was introduced for use with diethyl ether, but could have been used with other agents as well. The liquid anesthetic would be poured into the glass container. It would be carried up onto the cotton wicking. The wicking then would provide a surface for that anesthetic to be volatilized. The anesthetic gases would flow through, and a control valve at the top could be adjusted to allow varying amounts of flow to go straight through versus flow that would go down, pick up the anesthetic vapor, be blended, and then delivered onto the patient. So the flow was controllable because the dial let you pick different numbers. However, it was not calibrated, so there was no particular quantity that was associated with either a number 4 setting or a number 8 setting. Additionally, this vaporizer had no temperature compensation. So as the ether in the container would vaporize out, it would cool it down, and so subsequently even less anesthetic would be delivered. Additionally, this was used as a flow-through vaporizer. So gases that a patient would exhale would come back through and make another pass through here. Now that was important because it had 2 effects. One, since this added anesthetic vapor to it, depending on how much was coming into it, you got different amounts coming out of it. Additionally, as patients exhale, water vapor comes out. This is cold, and so you would get water condensing in here. The water condensing on it would further reduce the amount of anesthetic that was being added to the anesthetic gas mixture coming out. So it certainly could be used. It was used for a number of years, but it did have some limitations, and its ability to deliver a highly controlled concentration of anesthetic agent was rather limited. The Fluotec Mark II dates from 1957. It's of English manufacture with distribution here in the United States. In contrast to the Ohio vaporizer, which, while intended initially for use with ether, could be used with other agents, the Fluotec was made only for use with halothane. It was also a temperature compensated device. So if you look at it here, it has a method that you can add your liquid agent into the vaporizer. You could look at it and see here how much you added into it. It has a control valve on it. It is a definitive on or off, so you have to pull it out before you can rotate it to begin delivering the anesthetic to the patient. And once it's popped in, it doesn't deliver anymore. So that's a safety device that you can look clearly and to see if you're delivering some or none. If you would look within this vaporizer, you would see a bimetallic strip that adjusts the gas bypass to compensate for changes in temperature. It was used outside of the patient circuit so that only fresh gas flowed through it. And this was an advantage because since you knew what was coming in, i.e. none, then that reduced the variability in what was coming out of it. So the Fluotec delivered a more predictable concentration of anesthetic agent, specifically halothane, as compared to the Ohio No. 8. This improved control over the concentration of inhaled anesthetic was very important to the safe delivery of halothane. And while the delivery of the Fluotec Mark II was good at flows of about 4 liters per minute or greater, it became less consistent at lower flows. And as a consequence, the vaporizer came with a diagram showing delivered halothane concentration at different flows and settings, so that as the flow got to the lower end of the flow range, you could determine more accurately what was being delivered because the numbers on the dial became less accurate at that lower end. So the third vaporizer that I have today is the Dragerwerk Vapor from 1958. It's of West German manufacture with distribution in the United States. Like the Fluotec 2, the Vapor is an agent-specific vaporizer with temperature compensation. It too is designed for use with halothane only. There were certainly variants of these used for other anesthetic agents. However, the Vapor provides for temperature compensation in a way that is different from the Fluotec Mark II, which had the bimetallic strip in it. Now this one has on the top of it a thermometer that dips down into the vaporizer into a pool of the liquid anesthetic. So you can measure by looking at this and determine what that temperature is. On the top is an on-off switch. So again, you've got a definitive mechanism so that you can look at a glance and see that there is no agent coming out or perhaps some agent coming out. Once that lever is engaged, then you can rotate the dial to begin to deliver anesthetic agent into the system and to the patient. Now, if you look at this dial, you'll notice that there's a series of temperature-specific slanted lines. And by looking at the measured temperature of the anesthetic agent and then picking the corresponding line, the concentration dial setting could be adjusted to provide for a highly predictable halothane concentration. Now, as an additional feature, the Vapor contains a substantial amount of copper. This thing weighs a little over 30 pounds. And that provides for good heat transfer and greater temperature stability of the liquid anesthetic within the vaporizer. And as a result, the Vapor delivered a very predictable concentration of halothane vapor, even at quite low flows below 1 liter per minute. These three examples of anesthetic vaporizers help demonstrate some similarities and differences in vaporizer design and how anesthetic equipment needed to evolve as anesthetic pharmacology evolved. They are from the collections of the Wood Library Museum of Anesthesiology.